Okay, so 2, 3, if you open it, you will see is a beast of a section. Okay, there's 20 slides in this. We're going to go through a lot of stuff, polynomial and rational functions. So we're going to review synthetic division, we're going to review long division, and then we're going to apply them in a bunch of ways, okay? So we start with long division, and guess what? It's long, okay? It says it in its name. It's trying to warn you. If you remember long division, hopefully these steps seem familiar. If you don't, hopefully they'll jog your memory. When you're dividing using polynomial long division, so it would be something like these are just total made up numbers, but say like minus 3x plus 1 divided by x plus 1. Let's say something like that, okay? Then the first thing you're going to do is arrange the terms of both the dividend. This is the dividend. What you're dividing into is the dividend. What you're dividing by is the divisor. You're going to put them in descending powers of the variables. So you want the highest exponent down to none. And if you're missing a term, you're going to add in a term. So if missing a term, you're going to add in 0x to whatever power that is. So if I had an x to the third here, and I didn't have an x to the second, then I would add in a 0x to the second. You're going to do that for as many terms that are missing. So highest exponent down to none, adding in anything you're missing. Same goes for here. If this was x squared plus 1, then I would say x squared plus 0x plus 1. So for whatever terms are missing, you have to hold in their placeholders, okay? Otherwise, you can't divide. It doesn't make sense. The second thing is to start with the first on the outside and the first on the inside. So you're going to divide the first term under the division bar by the first term outside the division bar, just like you would normally do with long division with numbers. Whatever you get from that goes at the top, and then you're going to multiply whatever's at the top times each of the numbers on the outside. You're going to bring them underneath your terms. The exponents are going to match up. That's why we have placeholders. And then you're going to, and this says subtract from the product from the dividend. I actually would prefer that you change your sign and add. Reason being, the most mistakes that are made with this is when you try to subtract negatives, something just goes wrong. So it's easier to just change your signs and add. It is the same, but it is easier just to change your signs and add. Then you're going to bring down the next term in the original dividend and then repeat that whole process, dividing outside into inside, putting it at the top, multiplying it out, changing your signs and adding, and then you're going to continue that process until you are out of terms or the term on the outside's exponent has exceeded the term that you're dividing into. So I know this is words. Of course, we're going to go through the motions, but hopefully if you get stuck somewhere through the motions, you can come back to this and it'll help you jog your memory on what the steps are. All right, so we're going to start with this. It says divide 9x to the second plus 6x plus 5 by 3x minus 2. So I'm going to check to make sure that everything in my dividend goes from highest exponent down to none. I'm not missing any terms. Is that happening? Yep, I'm good to go. Then I'm going to look at my exponent, or what my divisor, do the same thing. Is it highest exponent down to none and I'm not missing anything? Yes, we're ready to go. So then I'm going to say 9x squared plus 6x plus 5 gets divided by 3x minus 2. Then I say first into first. So what do I have to multiply 3x by to get it to 9x squared? Good, 3x. And then that's going to get multiplied by both terms on the outside. So 3x times 3x is 9x squared. 3x times 2 is negative 6x. Then I'm going to change my signs and add. If you've done it correctly, the first column will cancel out. It did. And then I add positive 6 and positive 6, and I get 12x. And I bring down my next term. And I repeat the process. So what would I have to multiply 3x by to get to 12x? Positive 4. So I multiply by positive 4. Both terms, I get 12x minus 8. Change your signs First column cancels. And 13 is my remainder. So this is called my quotient. This is my remainder. And the way you will write these answers is the quotient plus the remainder over the divisor. So my answer is going to be 3x plus 4 plus 13 over 3x minus 2. So quotient plus remainder over divisor. It's like a big old mixed fraction. Now, if you had the time, and judging by yesterday's quiz, you probably won't, but if you had the time, you can check each and every one of these answers by multiplying these two together and then adding the 13 in, and you should get your question, okay? So if you have the time, you can always go through and check it. You convert it back into improper fraction just like you would do with a mixed number. Questions so far? Okay, this says x to the third plus 3x minus 2 by x squared plus 5x minus 3. So what's happening this time with my dividend? I skipped a term, right? I'm skipping x squared. So I'm going to add in the 0x squared. So I get x to the third plus 0x squared plus 3x minus 2 divided by, this is in decreasing degree order. There's nothing missing, so that's going to go on the outside. And then first into first. So what do I have to multiply x squared by to get to x to the third? Just x. This is x to the third plus 5x minus 3. Sorry, plus 5x squared minus 3x. Change your signs. First one cancels as it should. And then 0x squared minus 5x squared. So be careful there because people forget about that 0. This is negative 5x squared plus 6x. Bring down the next term, minus 2. What would I multiply x squared by to get to negative 5x squared? Negative 5. Multiply it times all 3. Change your signs. Cancels. 31x minus 17. So as soon as 1, I run out of terms. 2, the exponent on what I'm dividing into is smaller than I'm dividing by. I'm done. That whole thing is my remainder. So my quotient is x minus 5 plus 31x minus 17 all over x squared plus 5x minus 3. Mm-hmm. 5x. This is x squared. So I don't, because I already have this squared. What color? Okay, this is called the division algorithm. The division algorithm says that if the remainder is 0, then we say that the divisor divides evenly into the dividend, and the divisor and the quotient are factors. Okay? Think about this in terms of numbers. Okay? If I take 10 and 2, and I say, is 10 a factor? No, is 2 a factor of 10? What's the answer to that? Yes. How do you know 2 is a factor of 10? Close. It goes in evenly, right? There's no remainder. If I divide 2 into 10, it goes in evenly. That means it's a factor. Yes? Same goes for expressions. So if I divide x squared minus 2x plus 1 by x minus 1, and it goes in evenly, meaning that there's no remainder, or the remainder is 0, then I know x minus 1 is a factor of x squared minus 2x plus 1. Does that make sense? So that's what all those words mean. If you can take something and divide it into it with a remainder of 0, that means it goes in evenly, and if it goes in evenly, then whatever I divided by is a factor of the original polynomial.
For the problem before.
All right. Second kind of division we're going to do in this section is synthetic division. This is the one everybody likes. The good news is when you can choose, obviously choose this. The bad news is you will be forced to do long division because you can't do synthetic every time. And I'll tell you when. So the first thing you're going to do is the same step. Arrange the polynomial in descending powers with 0 coefficient for any missing terms. Then, given the divisor is x minus c, you're going to write c on the outside of the box. So this synthetic division looks something like this. A number goes on the outside. All the coefficients come here. Then you're going to bring down the first term. You're going to multiply what's on the outside by what's ever here. And then you're going to put it in the next column. And then you're going to add these two. You're going to get a number. You're going to multiply what's on the outside by what's there. And you're going to put it in the next column. You're going to add these. You're going to get a number. You're going to multiply what's on the outside. Put it here. You're going to add them until you run out of numbers. Okay? This is synthetic division. So there's no variables involved this time. This is when it's a lot easier. It's faster. The more you practice this, the faster you're going to get. Trust me, you're going to need to be fast at this. So it looks like this. 5x squared, 5x to the third, plus 6x plus 8 by x plus 3. So again, you want to look at these. Are you missing something? You're missing it, x squared. So I'm going to add in the 0x squared. And I write all my coefficients. 5, 0, 6, 8. These are all positive. If there was a minus in front of one of them, the minus goes with the number. Then I draw myself a little box. Sometimes people draw it this way. Some people, it doesn't matter. I don't care how you draw it. The opposite of what follows x goes on the outside. So -2 goes on the outside. I bring down the first term, multiply this, put it in the next column, add them, multiply it, put it in the next column, add them, multiply it, put it in the next column, add them. The last number is my remainder. And then the variables increase from no variable on the one next to it, x to the first on the one next to that, x to the second, and I would keep increasing as I move left. You can go that way. Or you can start with one less than your original function, which was to the third, and put that on the one on the left, and then one less, the last one's the remainder. So now this is 5x squared minus 10x plus 26. My remainder's -48. So instead of it being a plus, it's a 44. 44 over x plus 2. So if the sign on the remainder is negative, then the sign in between them is minus. If the sign in the remainder is positive, then the sign in between them is positive. So you cannot do synthetic if there's an exponent on the x of what you're dividing by, which is what's going to happen on your test. So you're going to get one in which it has an exponent. You're going to have to do long division. And then when you get to the synthetic, it's your choice. Okay? Obviously, I would choose synthetic.